Hello everyone. In this video we are going to see about left recursion algorithm. On the right side we can see types of grammar. There are two types, recursive grammar and non-recursive grammar. In recursive grammar there are two types, left recursive grammar, right recursive grammar. So now let's study about left recursion. What is left recursion? In a grammar, left recursion occurs when a non-terminal symbol can be written to start with itself. For example, A tends to A alpha or beta, where A is non-terminal symbol, alpha and beta are strings of terminals and non-terminals. What is right recursion? Right recursion occurs when a non-terminal symbol can be written to end with itself. For example, A tends to alpha A or beta, where A is a non-terminal symbol and alpha and beta are the strings of terminals. So let's see left recursion in detail. Left recursion is a grammar construct in computer science where a non-terminal symbol in a production rule appears as the first symbol on the right hand side of the same rule. This construct can lead to infinite recursion and ambiguity in parsing, making it an important concept in language theory and compiled design. Types of left recursion. There are of two types, immediate left recursion, indirect left recursion. Immediate left recursion. A grammar G is said to have immediate left recursion if it has a production of the form A tends to A alpha. For example, let's consider the following grammar where E tends to E plus T or T tends to T ampersand F or F, E tends to E or an ID. In the above grammar, if we see carefully, the first two productions, that is E tends to E plus T and T tends to T into F, the first symbol on the right hand side of the production is same as the first symbol on the left hand side of the production. So we can say that the grammar has an immediate left recursion in the two productions. So the next type is indirect left recursion. Left recursion involving derivations of two or more steps, so that the first symbol on the right hand side of the partial derivation is same as the symbol from which the derivation started is called indirect left recursion. For example, E tends to T, T tends to F, F tends to E plus T ID. Consider the following derivation, where we can see E tends to F, T tends to F, F tends to E plus T. Here we can note that in the partial derivation to get the string E plus T, the first symbol is E, which is the same as the symbol from which the derivation started. But the string E plus T is obtained from T by applying two or more productions. So the given grammar, even though it is having immediate left recursion, it has an indirect left recursion and hence the grammar is left recursion. Algorithm for left recursion. Let's say we are giving a grammar without any productions with no cycles and we are going to get output without left recursion. It may have epsilon productions. So what we do is arrange the non-terminals in the order a1, a2, a3 up till an, and we run a for loop where I is ranging from 1 to n and a nested for loop of j running from 1 to n I minus 1, and we name the productions ij tends to b1, beta 1, beta 2, beta 3 until beta k, and we start replacing these productions with ai tends to beta 1 alpha, beta 2 alpha, beta 3 alpha, and so on, and we end the nested for loop, eliminate immediate left recursion among AI productions, and end the for loop. Thank you.